Thanks for inviting me along today. As Claire said, I'm coming to you from Perth, which is the Whadjuk Noongar people's traditional lands, and I just want to acknowledge their elders and be thankful for the the opportunity to enjoy their beautiful part of the world, which I am at the moment. This little meeting I met with NICEN probably a year or so ago, and we talked a little bit about what this project looked like at that time. So now we're at the end of it, we can be a little bit more conclusive. And some of the stuff I'm going to go through may be covering a little bit of the same ground, but there may be some different people here, and it's important just to revisit some of that. So Claire, if you could just give me a click here. I'm just going to, Claire's driving this because I'm working off a phone because I'm travelling by bike in WA. So thanks, Claire. So what I'm going to focus on today is just to talk about what the 100% feasibility study was in terms of what we did and what we learned from that. And really, I suppose the first point about what we did was that we deliberately decided to have a sort of narrowly scoped project that was focused on proven technologies. So we didn't go looking at all the new developing technologies. We didn't look at hydrogen. We didn't look at compressed air and all those sorts of things. We kept it narrow and said, what's the potential for a solar plus pumped hydro system in and around Yackandandah, because it had been identified as potential sites, and also solar plus battery sites. The other thing is it wasn't like a generic feasibility study. It's quite commonly you'll see a feasibility study that looks at it, but it's not site specific. It just looks at numbers and, in theory, you could do this if you had so many acres. We went through a process whereby we invited expressions of interest from landowners and people around the town and anyone who had a little bit of land that they might want to, lease or sell. And we ended up having close to 30 different people expressed interest in the project, and narrowed that down to about five options over 4 different sites where we thought the most potential was. Obviously, a lot of those sites we discovered, were either too small, or they didn't have the right orientation, or that they didn't, weren't in a good part of the grid, or whatever it was. So that was quite a detailed part of the work that we went through. And then we spent the project was focused on what we called defining the viability gap. Now, I suppose I use that word advisedly because it sounds a little bit negative. But when we started this project, I think particularly the guys from TRI, and I know MCJ and Kim are present here today. We understood that at the scale where we're looking at these projects, it was difficult. It was going to be difficult to stack up a pure commercial business case for one of these investments. And so what we were really doing is trying to say, well, if we were to build one, what is the viability gap and how much money would we have to attract through grants to the table to make it work? And so that's really what the focus of it was. Throughout the project, there was a lot of community engagement sessions because, TRI always has wanted to sort of stay engaged with the community and bring them along with the learning. So there was quite a bit of community engagement activity going on as we went through. And I suppose when we got down to the 5 options on 4 different sites, a good way to think about how we looked at it is that we looked at it through a number of different lenses. And thanks, Claire. And the reason I say they're lenses is that quite often it's very easy to sort of narrowly consign the idea of feasibility just to the blue circle, just to the financial and commercial bit. With this level of capital investment, what's the revenue, what's the expense, and does it make money, does it make a commercial return? Of course, in the sphere we're working, there's so many other factors which really don't relate to that, but yet were very important to this feasibility study. Obviously, the technical question is, can it be done? Could it be done on these specific sites with the topography, with the current land use, all those more technical questions. There was also the issue of community energy resilience and the question of islandability. There's been a lot of talk about islandability in around Yackandandah and more recently in Corryong and Mallacoota, where in an emergency situation, it'd be nice to be able to switch off the grid and just have a continued mini grid working in your own local community. So there was that aspect to it. And of course, importantly, there's the environmental impact of what we do. What's the CO2 emissions impact? What do we say? So we sort of cast those four main lenses over all the work we did across the different options. Thanks, Claire. And this is where we're probably covering a little bit of ground. So the first thing is we needed to know what the footprint looked like. It might be a little bit hard for you, well, it's a bit hard to see because I'm looking at it on the phone, but maybe it's better for you on your screens. But you can see there where Yackandandah is and what the immediate township is. Try as a community organisation has a reach which they say is roughly an 11k radius around Yackandandah. It was linked to the physical infrastructure of the grid. And in there you can see the 22 kV network, which is in the sort of the purpley colour, and extending on from that, the blue lines, they're the swirl lines which come off it. And they're generally, I think, 12.5 kV or whatever the figure is. So thanks, Claire. If we could just show the next, that loop. So this, when we were talking to AusNet at the early part, we identified that there was a high voltage switch at I think somewhere near Patrice Vale, just up towards the terminal station in Wodonga, and we were able to isolate that area and say, okay, our analysis is going to be on that part of the grid, the physical grid, and that's where we started the process of trying to define the baseline. And so the first thing we went to AusNet and we said we want to get data, 3 years data on how much electricity goes through that high voltage switch on the line just outside Wodonga. Thanks, Claire. The interesting thing is that chart's gone a little bit skew-if, but I'll do what I can with it. The first thing that happened when we did that, so we got 15-minute interval data through that switch. And when we first looked at it, over the last 3 years, we identified, so that's the electricity we imported. Now, bear in mind here, we're in Yackandandah. We've got north of 57% of properties with rooftop solar. We had already identified this. And we were thinking, maybe we're making some inroads here to, to getting towards 100%. And then the data come back and it showed that the amount of electricity we import through the gateway at Patrice Vale was increasing year on year by 1.8%, 2.4%, and 2.3%. Now, when we first looked at that, we thought that's concerning. I thought it must be wrong to start with, because I thought what we would probably see is stabilisation of imported power, not increases. Thanks, Claire. I'm just going to see what this slide does. Yeah. So at the same time as those imports were increasing, we could see that the solar generation was also increasing steeply. Now, this wasn't a surprise because we knew that there was a lot of solar, rooftop solar and larger farm. I mean, there's big ones at the sports park, at the hospital. The hospital there might have been a bit before this period. But we knew there was a lot of solar installation going on. And bear in mind that green figure is the year-on-year increase in the electricity generated within the Yackandandah bubble. Now, if you put the two together, and they're working off a different base, if they're sort of not comparable, you have to sort of compare them. But if you put them two together, thanks, Claire. If you can just advance the slide, it gives us a picture of the consumption increases over those years that we estimated to have occurred. It was important to try and find out what consumption was doing to know what size solar and storage installations we need to consider for the future. And again, they looked for a place like Yackandandah with that growth, steep growth going on with behind the meter, that they're 5.1%, 6.3% and 6.9%. They were quite steep estimated consumption figures that were occurring here in Yackandandah. it wasn't really within our scope to sort of delve into that and to understand exactly why, except we think there was a number of things going on. The first thing is development. There's been a lot of development going on in Yackandandah, and we knew that, but it's certainly not in the order of 6%. But there is quite a lot of development. The second thing we think happened in this period with COVID is that if you look at total energy consumption across the national electricity market, you can see the graphs are quite stark. You can see that energy consumption across the grid really declined when COVID came along, mostly to do with industry, reduced production. And what happened is that, and that's what happened with the total electricity. But in Yackandandah, we don't have any industry. What we had is that people stayed home from work. So I suspect that we saw one of those. I can't remember which one. Probably would be the 1920, I guess. Was sort of COVID related. A lot more people who would formerly have gone to work in Albury-Wodonga were staying home and doing work from home. Perhaps. I can't prove that, but that's what we sort of thought might be the case. The third thing, and probably more relevant for other community energy organisations, and there's some reports. There was a University of Queensland report on this. We think that there is a tendency when people get their own solar panels on the roof and their own battery, that they get a little bit more carefree with their power. So in other words, more solar generation and battery storage doesn't necessarily, we would like it to translate into reduced imported electricity, but it's not necessarily the case. At least some of it, and there is evidence in the US and in Australia that says there is a tendency for people to consume more. And when we presented these findings to the TRI committee, a month or 6 weeks ago, there was a fair bit of nodding going on around the room, and people could see anecdotally in their own community organisations and in their own homes, they think, oh yeah, there is a little bit of that. So that's something we thought was a very interesting thing, a finding or thing we learnt from this project. Thanks, Claire. We might just move on. So this graph sort of shows over the period of the analysis, or over a longer period, actually, of the growth of the red line is the growth in the solar installations, the number of solar installations in terms of the percentage of dwellings. And you can see it's got to about, it's probably higher than that now, but this is data's about 12 months old, to 57.6. But you can also see the grey shaded graph. It illustrates the total amount of electricity that gets generated by those rooftop solar panels. And you can see the generation is growing more. And a lot of that's because, as you all know, the average solar panel has increased in size to the point that I think the Clean Energy Council said the average rooftop solar size in 2021 had got up to about 8 kilowatts. And if you compare that back to when the early uptake, 10 years ago, they were 1.5 and 2. So we're getting a lot more generation for the same number of panels. Thanks, Claire. I don't know what's happened there. Maybe, oh no, that's good. That's good. So what we also had to try and get our mind around is, well, this is sort of, I suppose, background, just showing what else is likely to happen in the future. So we've got a handle on what we think our consumption is, and now we're trying to find out, well, what's going to happen in the future. So this is a graph that shows the AEMO, the Australian Energy Market Operators, predicted demand consumption growth out to 2050. And interestingly, you'll see a lot of the business and residential normal use is pretty much stabilising in terms of the numbers, and all the growth is occurring in the sort of in the electric vehicle growth, starting in around, it's too small for me to see, but I'm suggesting it's around 2027 or thereabouts. There's a steep growth for electricity for use by electric vehicles. Thanks, Claire. So the other thing we had to do in estimating this, in this project, sorry, some of these numbers have gone skewy again here. Those numbers in the middle there say 28.5%. when we're estimating, we were trying to model when are we going to get to 100, when's Yackandandah going to get to 100%? And in doing that, the assumption up to when well, the early assumption was that we have to assume all imported electricity coming through the grid is non-renewable. But of course, we also know that that's not the case. We know that in about roughly a quarter of it, or a bit more than a quarter of it, currently is coming from renewable sources, and that there's a pretty steep growth curve happening in the renewable energy generation in the broad national electricity grid. So we modelled that and to try and work out, well, when, how fast is it going to go, and when is it going to get to 100%? Now, of course, that's a question that we couldn't answer. It's so dependent on political questions. We've got an election coming up, and but we made an assumption that that it'll get something close to 100% if the current trends continue by about 2040. Now, whether or not that's right, we don't know. Thanks, Claire. That's just a line that's gone skew in the translation, so we can ignore that. Thanks, Claire. We'll move on from that. Okay, so let's just quickly look at what the consumption graph looks like in Yackandandah. That's a typical winter's day consumption, and the interesting thing that came out of that was the 1 a.m. peak, and of course that's the hot water services kicking in. I think we talked about this at a previous meeting, which was interesting. Thanks, Claire. You might give that. The other thing is that line there, it's a smooth line. So in reality, the peaks and troughs are much spikier if you look at the consumption that happens in the actual consumption that happens in 5-minute intervals. It looks more like that. Thanks, Claire. So within that, so that's the actual consumption. So if you look at what's happening underneath that, you've got the solar generation profile that's pushing up underneath it. And of course, that's just eliminating the amount we have to import to meet that demand. Thanks, Claire. And the balancing fact, well, sorry, this just shows the across the analysis time. So this isn't on that day. That graph is just for one day, a typical July day. But across the year, we consume about 15,000 megawatt hours. The average load's about 1.7 megawatts. And it peaks out at just over 3 megawatts. And the total amount of generation in Yackandandah is around about 35% in terms of the quantum of electricity. Thanks, Claire. So the difference between what we generate is obviously the imported from the grid, and that's what tells us that we need both more generation and we need storage. Thanks, Claire. If you look at this, this is just the same graph showing the hot water peak at 1 a.m. And you can see it's got a slightly different shape. This is the import pattern as opposed to the consumption pattern, but that's the seasonal import pattern, seasonalized. So you can see that the highest is in the winter, but profile-wise, it's sort of pretty similar. And the lowest is in the summer, pretty much, isn't it? Yeah. So thanks, Claire. We can. So what do we learn? This is probably the important bit. There's lots of data here. So the first thing is we said if we just allow YAC to continue to build rooftop, build behind the meter, put batteries in microgrids as it's been doing, and allow that to happen, and also bank on the grid. The national electricity market, there's big solar and wind generation being installed in the system, then Yackandandah could expect to be, by our definition, around 100% by 2027. And I'm using the word ish. The reason I use the word ish is that there is so many variables here that can change this, and government policy and incentives are clearly a key to that, and the consumption side. Because as we saw earlier, if we just continue to invest in generation and storage, there is some evidence that suggests, well, we all tend to be a little bit profligate with that and a little bit wasteful, and we tend to think that that's okay. We feel good, so we tend to use more of it. In terms of islandability, what we learned, we came to a conclusion that islandability is still a very I think it's a good goal to aim for. But we also learned that in practice, it's very complex because of the way the current electricity grid is owned, and particularly with the DNSPs like AusNet Services. From their point of view, it's not easy for them to sort of hand over the keys to the grid in, just say, Yackandandah. And if they're in the event of a storm and they say, oh, that's okay, we'll just pull the switch and you can continue to operate, because they own the grid and they carry all the risk associated with what might happen if there's a storm, or if and you know, who are the technicians that are going to go out and work on the lines, and who carries that risk. So it got quite complicated. It's not just a matter of being able to, you know, put a big switch in and install batteries and generation. But I think it is something that can be worked towards. The third thing we learned is in the Yackandandah Valley, we're not Balranald, and we're not even Springhurst. What we have is very high value, intensely farmed agricultural land in quite undulating hilly landscapes. So there's a very high opportunity cost for using the land for, you know, particularly for solar generation, which takes space. Batteries, it's a different matter because it doesn't have that sort of footprint. So the ability to put solar generation, in particular in Yackandandah, proved to be a pretty challenging part of what we were looking at. So land use and opportunity cost of these things, we thought was a sort of a thing we learned. I think we knew that at the start, but we sort of proved it because it was very difficult for us to find, you know, a perfect, you know, spot for solar generation. So, in terms of pumped hydro versus battery, I'll start with pumped hydro. You know, I'm making the assumption people understand what pumped hydro is. It's a storage technology. It's not a generation technology. What we were really exploring is, does it have a role at a really small scale at consumption levels around Yackandandah? And the work we did showed that it is very hard to stack it up commercially at the small sort of you know, 5, 10 megawatt sort of scale. Very hard to stack it up. Now, having said that, MCJ sent me a link here in Western Australia, in fact, down at a town called Walpole. They've just recently announced, which is about 100, is on a transmission line about 125 kilometres north of Albany. I'm going to be riding through there on my bike in about 10 days' time, so I might go and have a look at this. But they've announced what they're calling, you know, Australia's first micro pumped hydro storage scheme. Now, I think that's great. I don't know how they've stacked it up, and I don't know what it looks like. But all I can say is what we discovered in Yackandandah is very difficult to stack up at these very small scales. I think pumped hydro comes into its own when you get into, you know, sort of orders of magnitude larger than what we were looking at in Yackandandah, I suppose. And I suppose compared to that, if you look at batteries, the lithium-ion batteries, they're much more scalable to the sort of level. And we already have a, you know, Yakko-1 battery, which people in this audience are probably familiar with. So, you know, the lithium-ion much more scalable. The pumped hydro sort of has a big flag fall for the civil works that are required, and tough to make it work. The other things with pumped hydro, we've got this thing called the round trip efficiency. So, you know, you pump the water up the hill and it uses electricity to do that. So there's a net use of the electricity. You're creating greenhouse gas emissions to pump it up there. And then you get to use it at a better time, you know, on the evening peak as it runs back down. We were quite disappointed in the round trip efficiencies. They were only, I'm working from memory here, they were something like 66% or 67%, I think. Kim or Matt might be able to remember that better, but you know, we sort of started the project and people were talking about, oh yeah, you'll get 80, 85%. Well, we didn't get anything like that once the engineers had done their work on the scheme on the sites we were looking at. A lot of that's to do with how high the hill was, how far the water had to travel to get to the bottom storage. So they were you know, they were geographic factors, they were physical factors rather than anything else. And the batteries, of course, if you want to get involved in the FCAS, which is the frequency control and ancillary services markets, obviously you've got more capacity to use a lithium-ion battery to play in those markets than you can with pumped hydro. Pumped hydro's got big spinning turbines, and you can't just instantaneously turn them on or turn them off for the 5-second responses to the grid. So over writing, I'm going to keep pushing on because people might want to ask some questions. The 5 options we addressed, it's sort of a disappointing thing for a person in my position to come back to my client and say, yeah, sorry guys, these aren't financially feasible. But pretty much they weren't financially feasible. And I just want to go through the reasons, and not that that was a surprise, but I think the gap in financial feasibility was bigger than we expected. And the reason it was bigger than we expected, I put it down to a number of factors. The first of these is the scale economies that apply to when you start working in these sort of grid scale installations that are grid facing, so front of meter. AusNet have got to tick all the boxes. You've got to get all the communications cabling in. They've all got to be schmick in terms of, I mean, it's all got to be schmick, but you get into sort of different cost territory. Most of the sites we looked at, we went to AusNet and said, how much is it going to cost? And they looked at it and they said, well, we've got to upgrade the lines for, several kilometres, and bang, there's $1 million before you start. So, you're spending millions of dollars literally before you get on site. Now, a lot of that is just to do with the state of the grid in and around the Yackandandah, adjacent to the sites where we had a line of sight to being able to build something. So it wasn't, again, it was site specific, where we had dealt with property owners specifically, and we felt there was a good chance of getting access to the land to do these schemes. So the other contributor, high, what I call flagpole costs. The second thing is the low wholesale spot electricity price outlook. Now, we sort of looked at what it's done in the last couple of years, and it's sort of an odd thing to say that we assumed a low electricity price when everyone today is talking about electricity price increases. And I need to make the point that when we submitted this report on the 1st of October last year, the first thing that was different is that there was no war in Ukraine. So just to give you a little idea of the magnitude of that event on how things have changed. So if we went back and redid this thing, I don't know what would change. I suspect we're not just going to go and redo all the figures based on the current world oil price or the current outlook for electricity price. But to give you a little bit of an idea, is that a few minutes ago when I went and looked at the coal price, the coal price. Coal is currently today selling at $332 US dollars a metric ton. Exactly 1 year ago, it was selling on the world markets at $84. So 84 to 332. Now, bear in mind, that's the source of energy for most of the electricity that gets generated in Australia today. That's the fuel. So the people who are bidding into those electricity markets, that's their cost of their fuel. So a lot of the assumptions we made on the 1st of October last year, are sort of all a bit up in the air. There's a similar thing going on with gas, as you only have to read the papers to find out about. So the point, I suppose the point, when we submitted this report, what we could see is that there was a large number of, quite a lot of new renewable energy generation coming on stream, particularly from South Australia through the interconnector. I can't remember the exact figure. I don't have the report in front of me, but I seem to remember a figure of 600 megawatts coming into the market. And of course, the thing about renewable electricity, it's got a low marginal cost because you don't have the fuel component to generate it. So what this all contributed to, and all the evidence was saying that the wholesale spot electricity price over the next few years is pretty flat. It wasn't looking like it's going to go up. And to make the relatively small projects we were looking at feasible, we needed higher electricity prices. The third thing here is that FCAS, I don't know how many people are familiar with, frequency control and ancillary services, grid services. We came to the conclusion that this is a really fast-changing and dynamic market, and we couldn't get a line of sight to how that was going to be the great white knight for these installations. A lot of people had pointed to the Hornsby battery, the big Tesla battery over in South Australia, which of course got fast-tracked after the big storm a few years ago. I'm sure most people have sort of read about all that. And the interesting thing is that a lot of people said, oh yeah, it sort of paid for itself in couple of years because of FCAS. And a lot of batteries that are installed, grid-facing batteries, have done very well out of revenue streams from frequency control services. We just are not sure that revenue stream will hold up in the long term for a smaller grid-facing battery solar scheme in a place like Yackandandah. So that's sort of what we learned. In terms of where to, I'm going to stop in a minute so people can ask. I've changed my. I suppose I'm speaking to community energy network members here, people who are in their own towns with their own challenges, and perhaps are thinking, well, where do we start with this? What do we do? I feel like the good thing we did, how we added value to Yackandandah is that we were able to sort of get a handle on how much we currently use. What is that usage passion? How much is it changing? What are people doing? What are the drivers of that? So I suppose in terms of what to do, get a handle on your current consumption, what your current solar generation inside your own little local bubble is, and that will inform a lot of what you then do. In terms of whether you're focused behind the meter, I think you always keep your mind open to front of meter installations, but keep investing in sort of small, bespoke, behind the meter type projects like rooftop solar and domestic batteries, and look at the consumption side. Try and find out, is hot water your peak at 1 a.m. Probably is. What can you do to help that? So yeah, keep focusing on behind the meter. Claire, I'm going to leave it there and see if people want to sort of ask some questions.